TRACE32 as GDB Front-End. TRACE32 as GDB Front-End, the roadmap development tools. TRACE32 as GDB Front-End. History. Introduction. The TRACE32 GDB Front-End is a software debugger solution which communicates via Ethernet or RS-232 with a GDB server and GDB stop using GDB Remote Serial Protocol (RSP). The TRACE32 GDB Front-End can be used to connect to GNU GDB server in order to debug Linux user space processes, to debug the Linux kernel via KGDB, and to connect to any kind of virtual target or a debugger implementing a GDB stub, for example, QEMU, QEMU, as front-end user for on the DB with reversible debugger. TRACE32 GDB front-end operates in two different modes, run mode and stop mode. The run mode is used to debugging a Linux user space process using the GNU GDB server or the OnDoDB target server. In this case, only the selected task is stopped when a breakpoint is hit. The kernel and all other processes continue to run. In run mode, a single program may have a more than one unit of execution, called thread, that share one memory address space. Each thread has its own registers and execution stack, and the debugger gets and displays the information about the running tasks from GDB server by using the dedicated remote serial protocol packets. On the other hand, the multiple virtual targets, for example QEMU, support the GDB remote serial protocol as a debugging protocol. In this case, we talk about the stop mode debugging since TRACE32 GDB front-end controls the whole target systems and not a single process. A breakpoint will thus cause the target system to stop completely. And in order to support symmetric multiprocessing SMP debugging over the GDB interface, the TRACE32 GDB front-end considers each core from an SMP system as a thread of execution. Thus, all the RSP package relative to the multi-thread handling are used for multi-core handling. Furthermore, some virtual targets support different core clusters which are considered as GDB inferiors. The GDB package for multiprocess handling are used for this purpose. Note, demo scripts for the TRACE32 GDB front-end are available in the TRACE32 installation directory under demo, etc, and GDB. Related documents. For information about using TRACE32 PowerView as a GDB backend, please refer TRACE32 as GDB backend. For information about Linux integrated run and stop mode debugging, please refer to the run mode debugging and manual Linux. For information about debugging virtual targets via interfaces other than a GDB, for example MCD or Caddy, please refer to the virtual targets user guide. I will read the three documents as well. Supported architecture. TRACE32 GDB front-end is available for the following architectures: 68K cold fire, 8051, X80 is M51, the ARM 32 and 64-bit, GTM, Hexagon, Intel X86, X86 64, MIPS 32 or 64, NIAS 2, Power Architecture 32 and 64-bit, RISC 5 32 and 64-bit, Super H, Tri-Core, V850, RH850, Xenta. Other architectures can be supported on demand. Please send your request to support@routeabout.com. TRACE32 setup. Configuration file. To configure TRACE32 as GDB Front-End, you need to add the following lines to your TRACE32 configuration file. The default configuration file is config.t32 and is located in the TRACE32 system directory. Mandatory empty line is here in PBI GDB and mandatory empty line. The example configuration for Windows, PBI and GDB, sys and temp, sys equal C drive T32, TMP equal C drive temp, screen equal font is smaller. For more information about TRACE32 in configuration, please refer to the configuration file in TRACE32 installation guide, page 35, installation.pdf. TRACE32 start. In case you are using the TRACE32 start utility to start the TRACE32 GDB front-end, you need to add a GDB debugger to your configuration. Please refer to the T32 app_T32 start.fm manual for more information about T32 start utility. Connection setup. This chapter describes the needed configurations in order to establish a debug communication between the TRACE32 GDB front-end and the following targets. A virtual target with the QEMU as the example. GNU GDB server, undo DB reversible debugger, K GDB. So debugging virtual targets. Multi-virtual targets include a GDB stub and can thus be debugged using the TRACE32 GDB front-end. We describe in the following the needed steps to establish a debug communication with QEMU. Example, connecting to QEMU. The following steps are required to establish a debug connection with the QEMU emulator. Start QEMU using the -GDB TCP : port number command line option or -S for the default port number 1234. 2. Start TRACE32 as GDB front-end. Select the target CPU from the system state window or using the system CPU command. System.cpu Jinc ultrascale ±APU. Define communication parameters TRACE32 using the system.port command. Example for localhost and default port number 1234. The system port localhost 1234. Set the remote target type using the command system gdb config gdb server off. System gdb config gdb server off. Establish the communication to the QEMU gdb stub using the system mode attach command. System mode attach. Protocol extensions. The protocol serial, a remote serial protocol, does not provide a way to distinguish between different memory types. When TRACE32 GDB Front-End is used to stomp mode to debug a virtual target. The memory address is not always sufficient to identify a unique physical memory location. Depending on the access mode, the same memory address could refer to different physical memory or memory locations. For example, secure, non-secure memory for ARM architecture. To overcome these limitations, Radbach has defined the following protocol extension. A packet, a read length addressable memory of type defined by access class starting at address Q TRACE32 memory access class and address and length. A packet to write length addressable memory of type defined by access class starting address. The data is given by the values. Each byte is transmitted as a 2-digit hexadecimal number. If the TRACE32 software version implemented this protocol extension, it must include the string T32 extensions plus and the Q-supported packet. Q-TRACE32 memory plus or T32 extension plus to indicate that extension for the read packet is supported. Q-TRACE32 memory plus or T32 extensions plus to indicate that the extension for write packet is supported. This will enable using this protocol extensions by TRACE32 GDB Front-End when required. The available access classes depend on the processor architecture in use, therefore refer to the access class memory class section of your processor architecture manual for details. GNU GDB server. The GDB server can be started in one of two different modes. Single process mode, also called target remote mode. In this case, the program to debug has to be specified on the GDB server command line, or the -- attach command line option has to be used to attach to a running process by specifying its PID. Example 1. Start the GDB server to debug the process. The binary hello from the start. GDB server : 2345 binary hello. Example 2. Start attach to the running process with PID 123. GDB server -- attach : 2345 and 123. 2. Multi-process mode, also called target extended remote mode. In this case, the GDB server can be started without supplying an initial command to run or PID to attach. The -- multi-command line options has to be used. Example: GDB server -- multi : 2345. In multi-process mode, the GDB extended mode has to be enabled. This can be configured in TRACE32 using the command system GDB config extended on. Moreover, GDB supports two different modes for debugging multi-threaded process: non-stop mode or all-stop mode. In all-stop mode, all threads of execution stop when the program stops. In non-stop mode, it is possible to stop single thread while other threads continue to execute. You can select the mode in TRACE32 using the command system GDB config nonstop, which is per default set to off. For more information about different command line options and debug modes, please refer to the GDB server documentation. The connection setup. The following steps are required to establish the communication with the GDB server. Select the target CPU from the system.state window or using the system.cpu command. Sys.cpu Cortex A9. 2. Enable the address extension in TRACE32, the power view using the command sys.option.mmu spaces on. This step is only required if the GDB server has been started in multiprocess mode. sys.option.mmu spaces on. 3. Define the communication parameters in TRACE32 using the sys.port command, system.port command. Example for a target address 192.168.188.50 and a port number 2345. Sys.port like this. And 4. Set a remote target type to a GDB server using the command system.gdbconfig.gdb server on. If the command is not used, directly to GDB Front-End tried to detect what kind of remote target is used. sys.gdb server on. 5. Use software breakpoints for assembly single stepping. This required if the Linux 3.x or newer is running on the target. System.option.step soft on. 6. Enable the non-stop mode if required to stop single threads. sys.gdb.nonstop on. 7. If the GDB server has been started in multiprocess mode, the extended mode has to be enabled using the command sys.gdb.extended on. Otherwise, TRACE32 will return the error target is not running. 8. Establish the communication to the GDB server using the system baud attach command. sys.baud attach. 9. If the GDB server has been started in multiprocess mode, the command task run and task attach can be used to start a new process or attach it to a running process. Example: start the process hello, task.run, user binary hello. Attach it to the process sieve with the PID 123. Task.attach 123. 10. Load the process debug symbols in multiprocess mode and the process space ID has to be specified. The single process mode data.load.elf sieve no clear. Multiprocess mode 0x7b is the space ID of the process sieve. Data.load.elf sieve 0x7b colon 0 no clear. The typical startup script for a single process mode. The resetter command: clear all TRACE32 power windows and select the target CPU and set the target IP address and a port number, and set the target type to the GDB server, and use software breakpoint for assembly single test stepping. Attach it to the GDB server and load the debug symbols of process sieve. The typical startup script for a multiprocess mode. Resetter command: clear TRACE32 power windows and select the target CPU and set the target IP address and a port number, and set target type to a GDB server, and set the extended mode. Use the software breakpoint for assembly single stepping. Attached to the GDB server, view the list of the processes, and start process sieve, wait 1.0, and read each space ID. Load the debug symbols of process sieve. Note: TRACE32 GDB front-end for Intel x86 can be used together with the x86 GDB server to debug native x86 Linux applications. Next is the multiprocess debugging. The processes of Linux may reside virtually on the same addresses. To distinguish those addresses, the debugger uses an additional identifier called space ID, memory space ID, that's specified to which virtual memory space an address refers to. The space ID is equal to a process ID. Threads of a particular process use the same memory space. Consequently, threads of the same process have the same space ID. The command sys.option.menu spaces on enable the additional space ID. A source code listing for process sieve is displayed as follows. A breakpoint to main in the process sieve can be set with one of the following commands. Please be aware of the process-specific breakpoints are breakpoints are set as soon as the process is started by go. On the DB reversible debugger, the TRACE32 GDB front-end can be used as a front-end for the OndoDB reversible debugger. The OndoDB target server allows to debug a Linux user space application as well as to record details of its execution. In addition to controlling the debug process, the TRACE32 GDB front-end also takes over the task of displaying the recorded data of the OndoDB target server in the TRACE32 PowerView user interface. Like tracing the code, the user has the ability to debug the application, going through the code both forward and backward, reverse debugging. So the TRACE32 GDB front-end automatically detects if it is communicating with the OndoDB target server and enables the reverse debugging commands. Go back entry, step back change, step back cover, and step back cover call, step back till expression is true, and reverse debugging mode. All control buttons and the list windows are displayed in yellow. In addition, the time of the recording displayed in the TRACE32 PowerView state line is referenced in reverse. KGDB. The TRACE32 GDB front-end supports debugging the Linux kernel using KGDB. Please note that it is only possible to debug the kernel space. K is kernel. Debugging the user space as supported by the TRACE32 start mode debugging for Linux is not possible. Example startup script for Linux kernel debugging via KGDB. Resettle commands. Clear all traces directed PowerView windows. Selected CPU. Enable address extension. Set the communication parameters, serial port. Attach to the KGDB stub and the Linux kernel. Load the kernel symbols. Load the Linux awareness. The program execution can be stopped by writing G to the process sysrq minus trigger. The troubleshooting. GDB Front-End system command. syscpu, select the process type. System mode, attach, down and up. Default down. The TRACE32 GDB front-end has no connection and a GDB server or GDB stop. When switching from up to down, TRACE32 GDB front-end sends a GDB kill packet to the GDB server or GDB stop. And no debug. The TRACE32 GDB front-end has no connection to the GDB server or GDB stop. GDB stub. When switching from a UP2 no debug up to no debug, the TRACE32 GDB front-end detach it from the GDB server or GDB stop. Attach. The TRACE32 GDB front-end establishes the connection to GDB server or GDB stub. UP. TRACE32 GDB front-end is connected to GDB server or GDB stub. Up cannot be used to establish the connection. Go standby, not available. This option IMASKASM disable interrupt while single stepping. Format on off, default off. If enabled, the interrupt mask bits of the CPU will be set during assembler single step operation. The interrupt mask ASM. The interrupt routine is not executed during the single step operations. After a single step, the interrupt mask bits are restored the value before the step. System opt IASKHLL. Enable interrupt while HLL single stepping. The default off. If enabled, the interrupt mask bits of the CPU will be set during HLL single step operations. The interrupt routine is not executed during single step operations. After single step, the interrupt mask bits are restored to the value before the step. System opt new spaces. Separate address spaces by space IDs. Default off. Enables the use of the space IDs for logical addresses to support multiple address spaces. This option needs to be enabled if the GDB server has been started in multiprocess mode. This option array. Enable array support. On, off with OVS. Default off, the on. The activated array extension and extended the address scheme of the debugger with a 16-bit virtual array ID. The addresses, therefore, have the format array _ID : address. This enables the debugger to handle array program memory. Off. The disabled port for code operates. With obvious, like option on, but also enables support for software breakpoints. This means that the TRACE32 write software breakpoints opcode to both the execution area for active arrays and a storage area. This way, it is possible to set breakpoint into inactive arrays Upon activation of the overlay, the target runtime mechanism copies the breakpoint OP code to the execution area. For using this option, the storage area must be readable and writable for debugger. Sys RES reset out. Restart the program being debugged by sending a GDB R packet. Reset target. System GDB config break soft. Use software breakpoint. Default off. When set to on, the TRACE32 GDB Front-End sets breakpoints by patching the corresponding address by a breakpoint instruction instead of sending a G or GRPS packet. sysgdb custom register.add. Set custom register. This command used to associate a user-defined register name with a specific access class and a memory address. sysgdb custom register reset. Delete all custom register. Reset the configuration defined by the sysgdb config custom register.add command, deleting all customer registers and associated parameters. sysgdb extended. Enable disable GDB extended mode. Fourth, when set to on, this command enables GDB extended mode, which makes the remote server persistence. If the remote server is the GDB server started in multiprocess mode, the extended mode has to be enabled. Otherwise, TRACE32 will return the error the target is not running as when establishing the connection. sysgdb GDB server. Remote target is the GDB server. As on, off, auto, default auto, on off. This option has to be set to on if the TRACE32 GDB front-end is connected to a GNU GDB server. Otherwise set to off. Auto. The default value is auto, which means that TRACE32 GDB front-end tried to detect the type of the remote target being used. If the correct configuration cannot be detected reliably, a non-GDB GNU GDB server configuration is assumed. That is, system D GDB config GDB server off. sysgdb config dot inferior ID. Set inferior ID. Set the inferior ID in the case of multiple inferior supported by the GDB stub. Monitor GDB monitor. Send monitor command to GDB backend. This command is used to send monitor command to the GDB backend. GDB config nonstop. Enable disable nonstop mode. Default off. This is duplicated. Enabling nonstop mode is only possible when the GDB server, that system GDB config nonstop on, will automatically set system GDB server to on. The nonstop mode is supported by multi-thread debugging with the following known limitations. Resuming from breakpoint is not supported for non-current threads. For Intel x86 and x86 and x64 architecture, if non-current thread hits a breakpoint, a program counter alignment issue could occur. Thus, it is always recommended to focus on debugging only one thread, current thread, at a given time. Sysport settings. BOR. Set communication settings. Set the communication parameters. You can use a serial or TCP communication. Host to Colombo port or combobulate. The GDB signal defines signal handling. Mode stop, non-stop, pass, no pass, print, no print. Define the GDB server or TRACE32 behavior when the application sends the signal signum. Signal number. No pass. Do not allow the program to see the signal. No print. No message is printed. No stop. This signal is ignored and the application continues running. Pass. Allow the program to see the signal. The program can handle the signal, or else it may terminate if the signal is fatal and not handled. Print. A message is printed in the area window when the signal is received. Stop. The debugger should stop on the signal. The GDB Front-End task commands. The following task commands are available for the TRACE32 GDB Front-End. Task. List tasks. List the learning processes on the target. Task. Copy up. Copy a file from the target to the host. Task copy down. Copy a file from the host to the target. The following task commands can additionally be used for multi-process mode. Task select. Select a task for debugging. Attach to a running process. Run. Start a new process. Kill running process. Detach from a process. Go. Start the execution of a single task. Break. Start the execution of a single task. Okay, today I read this material from the TRACE32, the company Route Bahu, the TRACE32 as GDB Front-End. Thank you for your time. See you next time.